What's up? I'm Vin, and I'm going over simplifying fractional expressions. So for this first example here, notice that we have a fraction and a fraction. So I want to get rid of these denominators here. And the way we're going to do that is we're going to multiply the top and bottom of the entire fraction by 1 plus x plus h and 1 plus x. Okay, so that's going to get the fractions in the numerator to simplify. So let's go ahead and do that. But we have to do this to the top and the bottom. So for the numerator, we're distributing to the first fraction and then the second fraction as well. So in the next line, we're going to have 1 plus x plus h. So we have 1 plus x plus h times 1 plus x. And that first fraction in the numerator is over 1 plus x plus h. And then after this, we have minus. We're doing 1 plus x plus h. So we'll just clean this up a bit. We have 1 plus x plus h times 1 plus x, and we are dividing by this denominator is just 1 plus x. And now our entire denominator is h times, we have 1 plus x plus h times 1 plus x. And now let's pay attention to the top here. Notice these terms cancel out as well as these terms. So in the next line, what we have is we have 1 plus x, which is the leading term here, so we could just get rid of the parentheses here. But then we have minus, and we have to keep the parentheses here for the 1 plus x plus h, because in the next step, the minus is going to distribute. And we're dividing all of this by h times 1 plus x plus h times 1 plus x. Okay, so now for the next part, we're going to send the negative through like this. Okay, so we're going to distribute the minus, and that's going to give us, we're going to have 1 plus x, and then we have minus 1 minus x, and then we have minus h. And all of this is being divided by, we have h times 1 plus x plus h times 1 plus x. And now look at the numerator here. We have 1 minus 1 canceling, x minus x canceling. And now this gives us negative h over, and we have h times 1 plus x plus h times 1 plus x. And notice now everything's attached by multiplication and division. We could cancel out common factors here. So we could do h divided by h, canceling out, and then we're left with a negative 1 in the numerator, and we're dividing by 1 plus x plus h times 1 plus x. Okay, so here is our first fractional expression simplified. Question 2, we have this fractional expression here, and same idea as the first example. We want to get rid of these denominators that show up in the numerator of the big fraction. So we can multiply by square root x plus h and square root x. Okay, so we're going to multiply by the least common denominator of what we see in the numerator. And if we do that to the top, we have to do the same thing to the bottom. Okay, so let's go ahead and do this. So we are distributing the two terms here to the first fraction and the second fraction. So in the next line, we're going to have radical x plus h times radical x times 1, which is just this here, over radical x plus h. And then we have minus radical x plus h. So just make that a little neater. So we have radical x plus h times radical x over radical x. And then in the denominator, we have h times radical x plus h times radical x. And from here, notice that these terms cancel out. We have matching factors, and then these matching factors cancel. So this brings us to the next line. We have radical x minus radical x plus h over, in our denominator, we have h times radical x plus h times radical x. But one thing I want to do is I want to multiply this by the conjugate of the terms that we have here. So I'm going to multiply by radical x plus radical x plus h. So let's go ahead and do that to the top and bottom. So we start to work this out. On top, I want us to think of the formula a plus b times a minus b. So we have a plus b times a minus b. Anytime you multiply two conjugates like this, you have a difference of two squares. That's a squared minus b squared. So in the next line over here, if I do radical x is my a term, radical x times radical x is just x, and then we have minus b squared. Our b term would be radical x plus h, and if we square it, we have x plus h. But we just have to make sure that we write it in parentheses, because when we subtract, the minus has to distribute to both terms. And now on bottom, I'm going to distribute. So we have the product of this term here with this monomial. So in a way, we're distributing like this. We're going to multiply these three things by square root x, and we're going to multiply those three things by square root of x plus h. So we have h. So let's see, over here we have h times square root x plus h, and then square root x times square root x is x. And then we have plus, so we'll make this fraction a little bit bigger. We have h, and then we've got square root of x plus h times square root of x plus h is x plus h. And then there's just that extra square root x. Okay, so we're just multiplying the terms together, but when we multiply square root x by itself, we get the x. And when we multiply square root of x plus h times square root of x plus h, we get x plus h. So now let's see how this simplifies. We have x minus h up top. So these terms cancel out right away. And then on bottom, what I want to do is I want to factor out an h. And see what we have. We've got square root of x plus h times x. So I'll just call that x times square root of x plus h. And then we have plus, if we factor out the h, we're left with x plus h times square root x. Okay, so we have x plus h. So we have x plus h times square root x. But now, see on top what we have after these terms cancel out, we have just negative h left. And we have h on bottom factored out, so these terms here could cancel out. So our final answer simplified here, we're going to have negative 1 over, and in our denominator, we have x times square root of x plus h, and then plus x plus h times square root x. Now, one thing I want to point out here, we might be thinking, like, why are we simplifying it exactly this way? Well, a sneak preview for calculus, one of your goals with expressions like this is to be able to plug in h equals 0 and to get an expression that's not something that's undefined. So notice if I plugged in h equals 0 here, I would have x square root x plus, and then I'd have another x square root x if h were to go to 0. But in the original expression here, if I were to plug in 0 for h, my original expression gives me 0 over 0. So that's the rationale for like why we're doing all of this algebra. It does have a purpose for calculus. Question 3, to simplify, we're going to multiply the numerator and denominator by the least common denominator of these terms here. So we're going to multiply by x plus h squared. So we have x plus h squared, and we're multiplying also by x squared. So this is going to happen here, top and bottom. And from here, we distribute. So we're going to multiply to these two terms over here. We're going to send this through. And in the next line, what we'll have is we'll have x plus h squared. So we have x plus h squared times x squared over the first denominator in the numerator is x plus h squared. And then after we have minus, and then we've got x plus h squared times x squared all over x squared. And then finally in the denominator, we have h times x plus h squared and then times x squared. So right away, I could see these terms cancel and these terms cancel. One thing that we're going to have to do is we're going to have to expand the binomial over here. Okay, so we're going to do this, but we'll call this over here our side quest. Okay, so we're going to go on a side quest for this part. And for this, we have x plus h squared is x plus h times x plus h. And this works out to, we would have x squared plus, if I go to the outside here, so I have x times h. If I distribute the h, I have h times x, or xh, and then h times h is h squared. So this simplifies to x squared plus 2xh plus h squared. Okay, so that's what I want to do with this piece over here, is I want to expand it to this form. So in the next line, we'll go ahead and do that. We've got x squared left from this part, and then we've got minus x plus h squared, which I just showed over here is x squared plus 2xh plus h squared. And this is all over h times x plus h squared times x squared. So from here, we could distribute the negative. We're going to have x squared minus x squared minus 2xh minus h squared. And this is all over h times x plus h squared times x squared. So see over here that these terms cancel out. Okay, these wipe out. And then we have minus 2xh minus h squared over all of this. But what I want to do in the next line is I want to factor out an h. So I'm going to take out an h on top, and we're left with minus 2x minus h. And this is over, we have h times x plus h squared times x squared. And see over here that h over h cancels out. So now we can write our final answer simplified. We have minus 2x minus h over, and in the denominator we have x plus h squared times x squared. Question 4, we have this square root with the fractional expression on the inside, but let's go ahead and simplify this. So the first thing I want to do is expand the term being squared on the inside. So we have 1 plus, and if we do x times x, because we're squaring this fraction, we do x times x is x squared. And then we're over, if we do radical 1 minus x squared times itself, that's just 1 minus x squared. Okay, so what was really happening here is we're just basically multiplying this fraction here by itself. Okay, so that was the algebra that took place, and x times x gives us x squared. The radical, when we multiply it by itself, it gives us the 1 minus x squared. So now from here, what we're going to do is we're going to make a common denominator for the first term, the 1 plus. So let's rewrite 1 in the next line as 1 minus x squared over 1 minus x squared. Okay, so I'm just rewriting 1 with a denominator of 1 minus x squared so that we can combine it with the other fraction. Okay, so we have plus x squared over 1 minus x squared. And now from here, all we have to do is just combine this into a single fraction. We have 1 minus x squared plus x squared, and this is all over, we have 1 minus x squared. So notice over here that minus x squared plus x squared cancels out. And that leaves us with this expression here. We have 1 over, and then we've got 1 minus x squared. But there's a nice property for radicals that when we have a fraction on the inside, we could split the radical up like this. Okay, so we could separate it like this, and the square root of 1 is just 1, and we will leave the denominator as the square root of 1 minus x squared. So here is our solution to 4. Question 5, we want to simplify this expression, and the first thing I'm going to do is expand this term over here. So we're just going to write, we have square root, and we're going to have 1 plus, and we're squaring this binomial, so we're going to multiply it by itself. We have x to the third minus 1 over 4x to the third times itself. So we're just going to write them side by side like this. So let's go ahead and multiply these two. So in the next line, we have this is all equal to, and we have the square root of, we have 1 plus, that's not being multiplied, so we just write 1 plus, and then we have x to the third times x to the third is x to the 6. We have x to the third times the fraction at the end would give us minus x to the third over 4x to the third. Okay, just know when we multiply a single term like this by a fraction, we just multiply the x to the third by the numerator. And then next, we're going to distribute this fraction. So we have minus 1 over 4x to the third times x to the third gives us another minus x to the third over 4x to the third. And then after this, we have the last terms multiplying to give us plus, and then we have 1 times 1 is 1, over 4 times 4 is 16, and then we have x to the third times itself is x to the 6th power. And from here, what I want to do is I want to find common denominators. So I'm going to turn each of these terms in the beginning into fractions that have a denominator of 16x to the 6. So that's going to be our least common denominator here. So let's go ahead and do that. So for the first term here, we have 1. I can rewrite 1 as 16x to the 6 over 16x to the 6. Okay, so that's how I'm getting the first term. The x to the 6, I'll just do the scrap work over here, and then I'll just write it over here. But x to the 6, if I want this denominator, I would multiply by 16x to the 6 over 16x to the 6. And that would give me, next I would have plus, and then I would have 16 x to the 12, because I'm doing x to the 6 times x to the 6. I'm just adding those two. And this is over 16 x to the 6th power. So next we'll combine these two terms here. Minus x to the third minus x to the third is minus 2x to the third. And this is over 4x to the third power. So if I want a denominator of 16x to the 6, I would need to multiply the top and bottom by 4 to make this into a 16. And then I need to multiply by x to the third to make this power bump up to x to the 6. So I have to do that to the top as well. So now these two terms together combine to make, we would have minus 8, because we're doing negative 2 times 4. And then we have x to the 6 over 16x to the 6th power. And then finally at the end, we have our plus 1 over 16x to the 6. So now we can move on. We'll combine like terms. We have a 16x to the 6th minus an 8x to the 6th power. So in the next line, we're going to write this as a single term now. We have the same denominator of 16x to the 6. But what we're going to do is I'm going to write 16x to the 12 first. We'll write this in standard form. So 16x to the 12. 16x to the 6 minus 8x to the 6 is plus 8x to the 6th power. And then we have a plus 1 at the end. So now it may not seem like we could do a whole lot more, but the polynomial on top, we could actually factor very nicely. This factors to, we would have 4x to the 6th power plus 1 times itself. Okay, so we have 4x to the 6 plus 1 times itself. A quick check here, 4 times 4 is 16. X to the 6 times x to the 6 is x to the 12. When we distribute here, we get a 4x to the 6, but then plus another 4x to the 6 to make 8x to the 6. And then 1 times 1 at the end matches this. And this is all over, we have 16x to the 6th power. And then from here, what we're going to do is we're going to rewrite this as separate radicals. And I could also write the top expression here as 4x to the 6 plus 1 squared. Okay, so we have 4x to the 6 plus 1, and this binomial is being squared, and we are over 16x to the 6th power. So now from here to simplify, we just have to be very careful. The top, we can just cancel out the square root in the square and say 4x to the 6 plus 1. The reason being 4x to the 6 plus 1, this term on the inside, is always positive. Okay, so we don't have to worry about anything happening here with imaginary numbers. However, when we look at the square root of 16x to the 6, we have to be careful. We cannot just say 4x to the third power. The reason being is that 4x to the third power has the potential to be negative when x is negative. And we can't have a situation where a square root sends out something negative. So to balance this out, we just have to put an absolute value around the x to the third like this. Okay, so this would be our final answer here simplified. A little bit more about this idea of the absolute value, like when do you need to include it? It's when the term that comes out has the potential to be negative. So for example, on the side, if I have the square root of x squared, here I can't say x, I would have to say absolute value x, because x on its own has potential to be negative. If I had something like, let's say, the square root of x to the 4, this, I could say for a moment absolute value of x squared, but x squared is always greater than or equal to 0, so the absolute value is unnecessary. For something like square root of x to the 6, this gives us x to the third, but without absolute value, this has the potential to be negative. Square roots can't sound out negatives, so this would need the absolute value. And then if I did something like, let's say, square root of x to the 8, this, I could say for a moment, absolute value of x to the 4, but x to the 4 is greater than or equal to 0, so the absolute value is unnecessary. But just be careful. It's a little detail, but it does make a difference. Question 6, we're going to simplify, and this time what we're going to do is factor out a greatest common factor on top. So notice what we have here is we have x plus 2 to the 2nd power, and we have x plus 2 to the 3rd power. So just looking at those two here, I could see that our greatest common factor from those two pieces is going to be x plus 2 to the 2nd power. Okay, so we could factor out an x plus 2 squared. And then the next factor I want to look at is the x minus 3. And notice here we have an x minus 3 squared and an x minus 3 to the 1st. So we could only take out the lowest power that shows up between the both of them. So here, for the x minus 3 factor, we could only take out an x minus 3 to the 1st. And now what we'll do is we'll write the leftovers inside of the brackets here. So if I take out an x plus 2 squared, I have no more x plus 2's left. I do have that 3 in front, so I'll just write the 3 over here like this. So we have a 3, And then we took out x minus 3 to the first from an x minus 3 squared. So we're going to have an x minus 3 left over. Okay, so we have x minus 3 left over like this. And then we have minus, if we take out x plus 2 squared from an x plus 2 to the third, we're left with a single factor of x plus 2. And then we're left with the 2 here. And we took out an x minus 3, so that's all that's left over here. And what we could do, I actually want to move this around. I'm going to use commutativity of multiplication. I'm actually going to write the 2 in front, and I'll put the x plus 2 after it. Okay, so I'm just going to go ahead and do this. That way, when we have to distribute in the next step, it'll be easier. So here, what we have now is we have x minus 3 to the fourth power on bottom. So right away, I could see that x minus 3 on top and bottom cancel, and that will reduce this power down to x minus 3 to the third. So now, let's see what we have. We have x plus 2 to the second power. And in the brackets here, so I'll just make this neater. So in the brackets, if I distribute, we're going to have 3x minus 9. And then I have to distribute a minus 2. Okay, so here, I'm not going to run into as much trouble. But here, if I forget to send the negative through, it's going to throw the whole answer off. So we have minus 2x and then minus 4. And this is all over x minus 3 to the third power. So now we could just simplify. We have x plus 2 squared. And then in the brackets here, now I could reduce them down to parentheses because we're just going to have a single binomial left. We have 3x minus 2x is 1x, or just x. And then we have minus 9 minus 4 is minus 13. And this is all over x minus 3 to the third. So here is our expression simplified. Question 7, we want to simplify this fractional expression. And I'm going to use these two rules. We have a to the b over c is equal to the c root of a to the b power. And we could also say that a to the negative b is equal to 1 over a to the b power. So I'm going to use these two rules. So I'm going to write this as we have 2 times the square root of 1 plus x. Okay, so I'm just going to turn this fractional or rational exponent here into radical form. And then we have minus x times this expression here, but that part, when I have 1 plus x to the negative half, this in 2 steps I could say is 1 over 1 plus x to the positive half, and then this becomes 1 over radical 1 plus x. So when I multiply x by this fraction, we have x over radical 1 plus x. And this is all over, we have x plus 1 on bottom. So now we want to get rid of this denominator in the fraction on top. So I'm going to multiply the top and bottom by radical 1 plus x. Okay, so let's just go ahead and do this. And we're going to distribute this to the 2 terms on top. So in the next line, what we have, we've got 2 radical 1 plus x times radical 1 plus x. And then we have minus x times radical 1 plus x. And this is over radical 1 plus x. And then from here, what we have in the denominator is x plus 1 times radical 1 plus x. We have to make sure that we write this in parentheses just to show that we're multiplying these 2 terms together. So here, these terms cancel out nicely. And then we have 2 times radical 1 plus x times itself is just 1 plus x. And then the minus x is the only thing that makes it after these terms cancel. And this is over x plus 1 times radical 1 plus x. So from here, what we could do is distribute. So in the next line, we're going to have 2 plus 2x minus x. And this is all over x plus 1 times radical 1 plus x. But now 2x minus x is just 1x. So I can write my x in front. I have x. I have a positive 2. And this is over, we have x plus 1 times radical 1 plus x. Okay, so here is our expression simplified. Just know if you want to write everything with rational exponents, you can also say that this is equal to x plus 2 over x plus 1 to the first power times x plus 1 to the 1/2 power. And you also have the option of saying x plus 2 over and just combining this to x plus 1 to the 1 plus a half is 1.5, or I could say 3 over 2. Okay, so this is also correct, but we could also write it this way. Question 8, our last example. And what we could do is we could rewrite this as the square root of 7 minus 3x. And then plus, for this part here, we have 3 over 2 times x. And then we have 7 minus 3x to the negative half. So just like the last example, we could rewrite this as 1 over square root 7 minus 3x. So we have 1 over square root 7 minus 3x. And we can combine this into a single fraction. We have 3x over 2 square root of 7 minus 3x. So I'm just going to write that last piece like this. We have 3x over 2 square root of 7 minus 3x. And all of this is over 7 minus 3x. So to get this stuff to cancel out, what we're going to do is we're going to multiply the top and bottom by the least common denominator here. So we're going to multiply top and bottom by 2 square root of 7 minus 3x. So this is happening on top and on bottom. So in the next line, we're going to distribute. And when we multiply here, we have 2 times square root of 7 minus 3x times square root of 7 minus 3x. The square roots are going to cancel, and we're going to have 2 times parentheses 7 minus 3x. And then we have plus, we do 2 times 3x is 6x. And then we have square root of 7 minus 3x. And this is over, we have 2 times square root of 7 minus 3x. And all of this is over a single fraction here. We have 2 times 7 minus 3x, I'm going to put in parentheses. Let's just make this a little neater. So we have 7 minus 3x in parentheses times square root of 7 minus 3x. So notice here that these terms cancel out. 6 divided by 2 is equal to 3. So now we can say in the next line, when we distribute here, we're going to have 2 times 7 is 14 minus 6x. But then we're going to have a plus 3x left over. Okay, so we have plus 3x left over. And this is all over 2 times. And for this part, what we could do is we could say, just like before, that this is 7 minus 3x times 7 minus 3x to the half. So why don't we just go ahead and combine them into a single term here. So we're going to have 7 minus 3x to the 1 plus a half is 3 over 2. And now we can finally write our answer. So our final answer to the last question, after we combine these two terms, we have 14 minus 6x plus 3x is going to give us minus 3x. And this is all over, we have 2 times 7 minus 3x to the 3/2 power. So this is our answer to the last question.